This video talks about SPM Mathematics Paper 2 for 2023. Question number 17. A1. The path of the water rocket is represented by the quadratic function f, x, equals ax squared plus bx plus c. State the range of the value of a. The word range means the possible values that the variable a can take. When you're asked to state the range of values, you should usually use inequality symbols, such as greater than, less than, greater than or equal to, and less than or equal to indicate the limits of the values. A in the quadratic function determines whether the function has a maximum or minimum. From diagram 12, the water rocket follows a parabolic path that opens downward. It goes up, reaches a maximum height, and then comes down. For a quadratic function, if a greater than 0, the parabola opens upwards, it has a minimum value at its vertex. If a less than 0, the parabola opens downwards, it has a maximum value at its vertex. Since the rocket's path opens downward, it has a maximum value at its vertex. The range of the value of a is a less than 0. 2. State the coordinates of the maximum point of the water rocket's path. The actual maximum value is given by evaluating the function at the vertex. From the image in question, the water rocket reaches a maximum height of 5 meters and lands 8 meters from the launching point. The path is symmetric, and the rocket lands at x equals 8 meters. That means the maximum point is halfway between x equals 0 and x equals 8. Median equals 0 plus 8 divided by 2 equals 4. Therefore, the coordinates of the maximum point are 4, 5. B. Table 11 shows a grouped data in 4 ranges of estimated costs. Let's calculate the standard deviation of the data. Step 1. The midpoint is the average of the lower and upper limits of each class. These midpoints will represent the estimated cost for each group. For RM 15 to 19, midpoint equals 15 plus 19 divided by 2 is equal to 17. For RM 20 to 24, midpoint equals 20 plus 24 divided by 2 is equal to 22. Continue with 27 and 32. Step 2. Calculate the mean. Divide the total fx by the total number of teams. Multiply each midpoint by the number of teams, frequency, and add them up. 5 times 17 plus 3 times 22 plus 6 times 27 plus 2 times 32. Then divided by sum of frequency, 5 plus 3 plus 6 plus 2. Mean equals 23.56. So, on average, each team spent about RM 23.56. Step 3. Calculate the standard deviation. Use the standard deviation formula for grouped data. Square each midpoint and multiply by its frequency, add them up. 5 times 17 square plus 3 times 22 square plus 6 times 27 square plus 2 times 32 square. Divided the sum of fx square by the sum of frequency, 5 plus 3 plus 6 plus 2. Then, deduct the mean square, 23.56 square. Square root the value obtained. The standard deviation is 5.23. 17. C. The water rocket is made of 3 parts: a hemisphere, a cylinder, and a cone. The given diameter of the rocket is 10 centimeters. Thus, the radius is half of its diameter. 10 divided by 2 equals 5 centimeters. All 3 parts have the same radius. The height of the cylinder is 4 times its radius. 4 times 5 equals 20. The height of the cone is the same as its radius. The height of cone is 5 centimeters. And the partial cylinder, of height, h minus 5. Calculate the value of h. Step 1. Find the total volume of the bottle. The volume of hemisphere. 2/3 of pi r cube. Plus the volume of cylinder. Pi r square h. Plus the volume of cone. 1/3 of pi r square h. Radius equal to 5. The height of cylinder is 20, and the height of cone is 5. Substitute all the values into the formula. Simplify to the volume respectively. The total volume is 13,750 over 7. Step 2. Calculate the value of h as shown in the diagram. The total volume, 13,750 over 7. And the volume of cone, 2,750 over 21, have been determined. If 1/3 of the volume of the bottle is filled with water, volume of water filled is 1/3 of 13,750 over 7 equals 13,750 over 21. Step 3. Set up the equation for water volume. The water volume includes partial cylinder of height, h minus 5, and full cone. Substitute all the values into the formula. Multiply entire equation by 21 to eliminate denominators. Simplify the equation. And the value of h is equal to 11 2/3. This is the height from the tip of the cone up to the water level. D. A student is testing 2 angles, 30 degrees and 45 degrees. To find out which angle makes the water rocket fly the farthest, a formula is given to find how far the rocket flies. L equals u squared divided by g, time 2 sine theta cos theta, where u is the initial velocity, 20 meters per second, and g is the gravitational acceleration, 10 meters per second square. Test with 30 degrees. Substitute the values of u, g, and 30 degrees into the given formula. L equals 20 squared divided by 10, time 2 sine 30 degrees cos 30 degrees. Simplify to 400 over 10. From the trigonometry table, sine 30 degrees equals 1/2. And cos 30 degrees equals root 3 over 2. The distance is 20 root 3 meters. Then, test with 45 degrees. Substitute the values of u, g, and 45 degrees into the given formula. L equals 20 squared divided by 10, time 2 sine 45 degrees cos 45 degrees. From the trigonometry table, sine 45 degrees is same as cos 45 degrees, both are equal 1 over root 2. The distance is 40 meters. Between 30 degrees and 45 degrees, launching at 45 degrees makes the water rocket fly farther. Therefore, 45 degree is the best launching angle for the water rocket. This concludes the SPM Mathematics 2023 Paper 2 revision. Thanks for watching, and may the effort bring excellent results. Good luck!